What's going on, guys? Let's do this problem right here. So we have the wind blowing on top of the roof and the area is provided, velocity of the wind is provided. The question is asking what is the force that required for this wind to rip off the roof, rip off this roof right here. So let's see how we can do this. So first of all, we can, so P is equal to F over A, F is equal to P times A. Therefore we have to calculate the pressure. So let's calculate that one. To find that one, I have to use the Bernoulli's equation. So according to Bernoulli's equation, P1 plus rho g y1, y is the height, plus half rho v. So this is I'm taking the top part as v2 and in the this one v1, right? So if I take this one, let's see what happened. v1 square plus v2 plus rho g y2 plus half rho v2 square. So this is the Bernoulli's equation we are using, Bernoulli's pressure equation. So let's see what we can cancel right here. Since the density of the air is very small, so the height doesn't make any difference. So we can cancel this one. And if we assume, so we are taking one as inside and two outside, right? Two is outside. So one is inside, velocity inside the house. Let's consider the house is windows are closed. But we can assume the velocity inside the house is 0. So this can be cancelled. So now we are left with P1, P2 and half rho V2 square. So let's calculate the pressure. So we have this equation right here, P1 minus P2 is equal to, that's what we have to calculate, the pressure difference, half rho V2 square. Half rho is the density of the air. That is actually density of the air is 1.29 kilogram per meter cube. So we can apply that one right here, 1.29 kilogram per meter cube. And the velocity of the wind is provided in miles per hour. Let's convert into meter per second, right? So let's convert. So if we convert this one in meter per second, that gives us 44.7 meter per second. And that is going to be multiplied this by this one, 44.7 meter per second square. And if we calculate this value, this one comes out to be 1288 Pascal. So we have the pressure difference right here. So this is delta P A. We can find the force right now. F is equal to delta P times A. So delta P is provided, we found out that's 1288 Pascal. And the area of the roof is given 200 meters square. So we can multiply that one, 200 meters square. That gives us 57,500 pounds. And that is the force required for the winds to rip up this roof from this house. And that's how it's done. I hope you guys like this video. See you next time.